Inequalities involving absolute value. Here we're going to start off first with linear expression inside the absolute value, and then we solve for the inequalities. And then we have one case for less than k, where k is a positive value, and another case wherein the absolute value is greater than or equal to k. Now, to solve for this, we have to solve for this linear inequality wherein ax plus b is less than k and ax plus b is greater than or equal to negative k. Now, the other one is you're solving for either ax plus b is greater than k or ax plus b is less than or equal to negative k. Let's start off with a simple x in our absolute value. Absolute value of x is less than 3. Let's draw the number line to illustrate this. So we're looking for all the numbers that would be less than 3. So this would be all the numbers less than 3. Let's say from 0 to 1, we all know that the absolute value of this is less than 3. But we also have some negative numbers that will also give us an absolute value that is less than 3. They are numbers from negative 3 to 0. So our solution for this one will be from negative 3 to positive 3. If we just look at the real number line. But if we look at the solution here, I'm going to divide this into two parts now. So that means x here is less than 3, okay? And the other one is x is greater than negative 3. Okay. So why do we need an end? Okay. I'll be using the blue one to show you the line graph for less than 3. So when you draw less than 3, this is from 3, okay, all the way to negative infinity. Okay. And when we draw this solution greater than 3, it would be from negative 3 all the way to positive infinity. So if we're going to do OR, then that means you're looking for all real numbers. But when we just look at the line graph earlier, we already know that the answer should be the numbers from negative 3 to 3. So if we consider these two blue lines, how do we get this interval? If they are the intersection of this solution and this solution. That means where the two lines will appear on the real number line, the portion. Okay, so the answer is, you can write this from x less than 3, okay, and greater than negative 3. Instead of doing this separately, we can write it in this manner. Now, how about for this one here? You're saying that x, absolute value of x is greater than 3. So again, let's just use our real number line. So if this is 3 and we want greater than 3, then we're eyeing for all the numbers greater than 3. But there are other numbers who will also have absolute values that would be greater than 3. If we have negative 4, negative 5, their absolute values will also be greater than 3. So it's this numbers or this number. So x less than negative 3 or x greater than 3. So for this case, we need OR because the numbers here and here will not intersect. But if you look at the first case here, okay, if we solve it separately in this manner, they are going to overlap and we're looking for this one. Okay. So it's either you write it down this way or you just write it in this format. Okay, let's have more examples. First problem, we have 8x minus 3 less than 21. So this is less than 21 but we can write it in this form, greater than negative 21. Okay, instead of doing n, so that we don't have to find the intersection. So what we do, since we want to isolate x, I'm going to add 3 to all of the sides so that we'll be able to isolate our x. So this is 8x Negative 21 plus 3 is negative 18. And this is 24. And we want to divide all of the sides by 8 to isolate x. So we have negative 9 over 2. We can simplify. They are both divisible by 2. And then this is 3. So our final answer in interval notation is negative 9 over 2. There is no equal here, so we're not going to include the number itself. Okay, then up to 3. Now for this one, it's the second case. You can rewrite this such that your constant is on the right side. Okay. This just means that this is greater than 3. So I can just rewrite it. Okay. So that means I want x plus 4 to be greater than or equal to 3. So on the numbers greater than 3, or x plus 4 less than or equal to negative 3. We're just solving two simple linear inequalities. So x greater than or equal to negative 1, okay, or x less than or equal to 7. So when you write down the interval notation, less than 7, negative infinity to negative 7, we include negative 7, union negative 1 to positive infinity. It's a little bit challenging when you have quadratic equations. So if you look at this one, same thing as what we did earlier. We want this expression, okay, to be less than 1. Okay, and so here this will be useful to have the end because we want to solve for this separately. It's not easy to solve quadratic inequalities with 3 sides at the same time. And let me use a different color. X squared minus 5x plus 5 is less than, greater than negative 1. So I'm just writing the constant on the right side instead of having it on the left side. So how do you solve for quadratic inequalities? First, we transpose 1, so that's plus 4, less than 0. So we first write this as quadratic equation and look for the zeros of this one. So that's x minus 4 and x minus 1. You can double check by the inner product and outer product. So the zeros are 4 and 1. So we make a table. So the intervals are negative infinity to 1, 1 to 4, 4 to positive infinity. Okay. We pick a test number. So let's see, 0. Then choose 2, 5. And we substitute that to these two factors here, x minus 4, x minus 1. And we're going to multiply these two. So let's test the numbers. So 0 minus 4 is negative, 2 minus 4 is negative, 5 minus 4 is positive. 0 minus 1 is negative, 2 minus 1 is positive, 5 minus 1 is positive. Then we multiply by just looking at the sign. So negative times negative is positive. This is negative and this is positive. So what are we looking for? We're looking for this expression to be less than 0. So that means the product of this is less than 0. It's negative. So your solution for this part here, for the first one here, the solution here is negative 1 to 4. Because it must be a negative number. So we're going to do the same thing here. We're going to solve for this quadratic inequality. X squared minus 5x transpose negative 1 plus 6 greater than 0. So again, we factor this, equate that to 0 and factor. I'm going to factor it right away. Minus 3 x minus 2 equals 0. So the zeros of this is 3 and 2. Okay. Then again, we construct our table, the intervals, negative infinity to 2. Then we have 2 to 3, 3 to positive infinity, We pick a test number. So 0 is here. There's no whole number in between, so we don't have a choice. Let's do 2.5, and this is 4. Then we get the sign of this expression, x minus 3, x minus 2. And then at the end, we multiply these two signs. So 0 minus 3 is negative. 2.5 minus 3 is negative. 4 minus 3 is positive. 0 minus 2 is negative. 2.5 minus 2 is positive. 4 minus 2 is positive. So when we multiply these two expressions, we just get the sign negative times negative, positive, negative, positive. But what do we want? We want this expression to be greater than 0. So that means this product here should be positive. So our solution would be these two values here. So take note, we're looking for the solution that will satisfy this and this. So for our final answer, we're going to look at the intersections of the two. So this is a real number line. The solution for the first one is from 1 up to 4. Okay, so this blue. And then the solution for the second one is negative infinity up to 2 and 3 to positive infinity. So since we have to satisfy all the numbers that would be true to this inequality and will also satisfy this inequality n. So we're looking for the intersections of those two lines. And the intersections of those two lines will be this part here. This portion here, that would be the intersection of these two lines here. So our final answer will be from 1 to 2, union 3 to 4, where they will intersect. So why didn't I include 1, 2, 3, or 4? Because there's no equation, or so there's no equation of equal to 1. Okay, it's just less than 1. You'll have to do a little adjustment if this problem becomes greater than. So instead of and, if this is greater than, this becomes or. But you still have to solve for two different quadratic inequalities.